Lesson 7, Black and White Images. In this lesson, you will learn how bits can be used to represent the individual pixels of a black and white image. And you will be able to explain how sampling is used to create a digital form of an analog image. You'll also learn the difference between a digital and an analog image. Now, for your warm-up, what I first want you to do is think about this prompt. You recently did some online shopping and you're expecting the package to arrive in about a month. The delivery service has a tracking system which reads the location of the package. How often would you want the location to be read? Would you like to see it every week, every day, every hour, every minute? How often do you want it truly updated? How often is it really important for you to see it updated? And be ready to explain your answer. Since this is just the recorded version, nobody's going to provide answers. In class, I will be asking for your responses. And any one of them could be right. Just use your explanation, okay? It's a month out. I don't think I need it every minute. I'm not going to be checking every minute. Every hour, still, probably not because it's a long ways out. Every day, I don't know. I don't know if every week is too slow. I might like it every week until we get to the week that it should be coming, and then I might like it updated every day, just in case it's coming faster. I don't know that I ever need online shopping updated every hour or every minute in terms of tracking, but maybe you do, and let me know why. Now, if you had shared insights or if you were in class, I would thank you for sharing your insights and would note that it seems to depend on the situation. How far out is the shipment? How long should it take? As to how often you want it updated. Sometimes we want to take a reading of the location more frequently than others. Today, we're actually going to learn about how images are represented in computers. Now, as we do that, I want you to keep in mind the idea about how often you take a reading or a measurement of something. You know, the activity guide. If we are in class, you will receive an activity guide. If we're virtual, the activity guide is available online in the Canvas course. You want to view the guide online, and then you can record your responses in your notebook if you prefer, or you can print the guide out and record the responses directly on the guide itself. Your choice. Now, what I'd like for you to do is sit right back and enjoy a show about a pixelation widget. Now, this pixelation widget, I can't play a video in a video. It doesn't save nicely here. So at this point, I would tell you to pause this video, go back to Canvas, and we're going to Canvas and click on the pixelation widget. The video that you will see will be actually displaying an old version of the pixelation widget. In the version you will use, you no longer need to set the width and the height using the binary numbers. Instead of using binary numbers, you're going to have a slider at the top. And I'll show you what that looks like in a couple of slides as well. You may also note that the width and the height is not displayed in the workspace in binary numbers. Okay, it's just a little bit of a difference, but it wasn't worth remaking this whole video. So you want to pause the video, go and watch the video on Pixelation Widget. Did you watch the video? If you did, that's fantastic. So, now that you had a chance to see how to set each pixel, black or white, we're going to use that widget to represent an analog image using a process called sampling. First, what is analog? It's a term that gets bantered around a lot, but I'm sure like a lot of terms that are out there in use, you might not feel comfortable with exactly what it means. Well, analog is a term used to mean something with continuous representation, such as a picture that you draw on a piece of paper or paint on a canvas. Each pencil line is smooth and it connects easily to the next, no matter how much you zoom in on the picture with a magnifying glass. When we represent an analog image digitally, we will have to make some choices on how to sample the image to get the smoothest representation possible, while keeping in mind the number of bits it takes to build that image. What does it mean to sample? Well, it means we're choosing how small to make each section of the picture. we look at when deciding on whether or not to make it black or white, because a pixel is represented by a bit. It's either on or off. It's black or white. So the smaller the sample, the more pixels are required to represent that image. Larger samples require less pixels, but the image can become quite blurry. You're going to try it out for yourself here in a minute. Now this is basically what the Pixelation widget looks like. Okay, what I forgot to say was, at this point in time, if you haven't already, I'd like for you to log into Code Studio and find your way to Unit 1, Lesson 7. You'll notice at the top of the page, there are places where it tells you what level you're on. Right up here, you'll see little diamonds and you'll see 1 and 2. If you want to see levels 1 and 2, first thing is to just play with the widget. So that's what I'd like for you to do, is just play with it. Turn it on, turn it off. Just make a little picture, see what you're doing, okay? When you're done, come back and take a look here, and we'll continue. Okay, now that you're back, we're going to look at levels 3 and 4. You're going to recreate the letter A using the black and white pixelation widget. You must first enter the correct number of binary numbers to enter the width and the height of the page, and it's really not entering the correct number. Let's get this guy going. Right here is where you've got your height and your width, your height and your width. And you're just going to take the little slider and you can move it out and back wherever it needs to be. Okay? Then you're going to enter a 0 or a 1. 0 for black, because black is the absence of all color, and 1 for white, as white is the presence of all color. When you're done with level 3, I'd like for you to move to level 4, which just means clicking to the next page. And you must find and delete the extra bit that is somewhere in that, in all of this, that's causing the image to be distorted. At this time, I'm going to click the timer and give you 10 minutes to do it. If we're in class, I would literally wait for the 10 minutes to be up. Here, I'm simply going to tell you, please pause your video and take about 10 minutes to work through these 2 levels. When you're done, come back and continue the video. So, pause the video and, oops, that's not working now. Pause the video and go ahead and start working through the levels. Now that you're back, we're going to look at challenges A and B, which are levels 5 and 6 in Unit 1, Lesson 7. You're going to read the values from challenge A, black or white for each square, and input the values into the widget. After challenge A, I'd like for you to answer the questions on the activity guide or in your notebook that are being asked from the activity guide. You're going to repeat for challenge B. So at this time, if you have not already, you need to download this activity guide onto your computer and open it up so you can refer to it back and forth. If you've got 2 screens, all the better. If not, you'll just have to use split screen or go back and forth between this and the Pixelation widget. Or obviously you could print this out. For challenges in level 5 and 6, challenges A and B, I'll be giving you 12 minutes in class. So this time, go ahead and pause the video and create the picture and answer these questions over here after you've created each one. Go ahead, pause, and go. All right. So now that you've done this, if you haven't done challenge A and challenge B, please do it beforehand. Right? It's part of the learning in this class is really just going through the exercises and experiencing it. Now, when you finish sampling, you want to reflect on the following. How many total bits were needed to recreate your picture in challenge A? Online, I'd be asking for some answers. Here, I'll tell you, you needed 48 bits of pixel data. How did you get that? 1, 2, 3, 4, 5, 6. This picture is 6 wide and 1, 2, 3, 4, 5, 6, 7, 8 tall. So you were noting whether it was white or black for each one of these pixels. In other words, this first one was white, or should be a 1. This one, it's mostly white, so it's also a 1. Then you would have 2 and 2, and you'd be back, or 2. Sorry, 0, 0, and back to 1 and 1. So really what you wind up with is a white, white, black, black. It's probably not going to look real good, but go ahead. Now, when you finished, did the digital image resemble your analog picture? Why might the digital not resemble this one? You should have your thoughts written down. My answer, it does not look like the original image. We could only represent each square with black or white. So many of the squares had both black and white parts. So we lost a lot of detail. Now, what I want to do here is just go through and kind of show you what your image should have looked like. Okay. So here, Control P. I'm going to give this one, oops, going to make it black and black. Now, I'm just going to cover this up with, oops, with squares. With the squares, just like you would have in the widget. Okay. So first off, let me make these into infinite cloners. Okay. So again, this first one would be a clear, or would be a white. Okay. This next one would be white. This one you would have done as black. This next one would be black. Then you would have 2 white ones. On the next row, I think it would be white, black, white. So I'm going to have white, black, white. This one, it's probably more white than it is black. So if we're being honest, we would put a white, and then we've got a black one, and then a white one. Over here, we could go with black on that. This, that's going to be white, more than likely. Some of these, if you did black instead, that's fine. These next two are definitely white ones. And this last one, these last two here are also white ones. There's just not enough black there to say that it's more than half black. Now, black, black, okay. There's black and black. And then we're going to have a white and a white and a black. And this last one here, you could go either way, okay? Black or white. I think there's actually more white there. Okay. Down here, this one is still probably more white. Then we're going to have 1, 2, 3, 4 blacks. So 1, 2, 3, 4 blacks, and a white. Then we're going to go white, and this one right here, it's somewhere in between. So if you want, we can even say that it's, if you said it was black, that's fine. If you said it was white, that's fine. These two are obviously, this one, we'll go with a little bit less, so we'll make that one a white one. And then you had a white one. Now down here, if you notice, in each one of these pixels, or each one of these squares, there's more white than there is black. So everything here is going to wind up being white, even though there is black, right? So notice, this is kind of what your picture is going to be looking like. I'm just going to fill in the other ones that have got enough black so we can sort of see. Okay, so you probably only got something that looked kind of like that. We lost a lot of detail. Well then, what happened here in Challenge B? What's different between Challenge A and Challenge B? Well, we're going to sample more. Okay, we're going to be sampling more frequently across the image by using smaller squares. We're going to break the picture up into smaller pieces. How many total pieces were needed? Well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 12 by 16 is 192 pixels. This probably took you longer, or it should have, okay? And your answers are going to vary. Some of you did it quickly, some of you did it slowly. But this one will take you longer. You've got to set 192 pixels instead of 48. How does the new digital image compare to the one from sample A? What effect did taking a larger number of samples have on the image? Well, in your notebook, you should have written down that the image looks a little more like the original. Still not real accurate. Still a lot of boxy lookingness to it. Okay? You should have been able to approximate the detail of the image a bit better with more samples, but we're going to need a lot more samples of much smaller squares in order to make this picture look really good. Okay? Now, samples or challenge C. Here, you want to select your favorite company logo. And it could be Amazon, it could be the Nike Swish, it could be Adidas, anything, just a company logo. Decide how you're going to sample the logo. Okay, and you've got some grids. If you print it out, if you didn't print it out, then you want to overlay essentially your logo with a grid map so that you can decide if it's black or white. On the activity guide, you had 4 different ones, very large to rather tiny squares. You want to draw the logo freehand. Then you want to recreate the logo in the Pixelation widget on level 7. Now, you're not going to be able to show it to a classmate if you're just watching the video, but you can kind of look at it. You can see if your parent or sibling recognizes the logo. Make some adjustments if necessary. Obviously, if you use this first one, you might need to at least go down 1 or 2 levels smaller so that it can be more recognizable. Okay, which means that you would need to increase the sampling. So for this one, I'm going to give you 15 minutes. I don't want you to do a really detailed, complicated company logo, just a basic one, but one of your choosing. So go ahead and pause the video and do challenge C. Great. If we're in class, I would then ask for a number of you to share your screen to show what you drew. Okay, and we would go around and we would see several of them and see how it looked, and you could explain the difficulties that you encountered or what made it harder, what made it easier. Continuing on with the wrap-up, in challenges A and B, you and your partner, we didn't do partners online, you practiced sampling the same image twice. The second time, you did it more frequently, okay, by using smaller squares. What are the pros and what are the cons of sampling an image more frequently? There are both pros and cons to sampling it more frequently. Take a moment and jot down your thoughts, your response. Okay. Again, pause the video if you need to. I would also just ask for people to share in video. We're not going to be sharing since you're just watching this by yourself. Okay. But when asking students in classes previously, it appeared that there were several advantages and disadvantages when it came to sampling something more frequently by using smaller squares. We get a better approximation of the analog image when we do more frequent sampling, and it was a little easier to decide whether each square should be set to black or white. The more you zoom in on it, the more you can tell if the thing is all black or all white. However, it took longer, and you needed a lot more bits. So for more frequent sampling is clearer, easier to do, but it takes more time and more space. We still got an image that didn't represent the image accurately enough, though. Unless you've got a really basic boxy image, you're not going to be able to represent it very well doing what we're doing. Fortunately, a computer does this process much more quickly than any of us can do. Okay, and it can store thousands or even millions of bits to represent an analog image. That would just take way too much time. By this point, we've used bits to represent numbers, text, and images. The same sequence of bits can represent different types of data depending on context. It all comes down to zeros and ones. Eventually, we're going to learn how the computer can tell the difference between numbers, text, and images. As a little bit of a foreshadowing, information about data or data about data is called metadata. We're going to hear that term again. You don't have to worry about it right now, but eventually you will. Now, analog data, if you don't have these terms written down, you may want to write these down. These are vocabulary words that you're going to be responsible for at the end of this unit. Analog data. It's data with values that change continuously or smoothly over time. Some examples of analog data include music, colors of a painting, or position of a sprinter during a race. We've got an image and a sound. Okay? If you think about sound, that would be record players, things like that, versus a CD or a digital recording. Actual hand-painted paintings, analog, computer renderings of the same painting would be digital. Digital data, data that changes discretely through a finite set of possible values. If you zoom in close enough on any digital picture, it will be black or white. Sound likewise. You're going to hear something or you're not going to hear something. It's digital, on or off. Now, sampling is a process for creating a digital representation of analog data by measuring the analog data at regular intervals called samples. So each bit here was a sample. Each bar here would be a sample. Notice in this bar, there's no sound. In this bar, there's a sound, and it's at this level. In this bar, your sound level is here, and there's a sound. Over here, no sound, no sound. Digital. The next lesson we do will be color images. So computers do black and white. They also do color, and we're going to find out how next.